Hi, it's Mr. Polochak, and we're back in the classroom today. I'm going to go over a lab where we look at the effect of molarity on a potato core. So I have a potato here. I've got my different molarity set up. I have a cup with distilled water, and then a 0.2 molar, a 0.4 molar, a 0.6 molar, a 0.8 molar, and a 1 molar solution of, it's a glucose solution. Now, let's just talk really quickly about what this means as far as the molarity of these solutions. Think of it as like mixing lemonade in water to get, this would be a really, really sweet lemonade at a 1 molar, and this would be like a lemonade where we've mixed hardly any lemonade mix in the water, so you can't really tell that it's very, flavorful. Okay, so that's what we're talking about with molarities. It's how much of a solute is dissolved in a solution. So a 0.2 would be very low. I'm sorry, here's the 0.2. 0.2 would be very low, and the distilled water is just pure water with no solute in it. Now, for this particular lab, you're asked to figure out what the molarity of a potato cell would be. And what we're going to do is run this experiment with these potato cores and look at percent change in mass. And when we graph that, we'll be able to determine the molarity of these potato cells. Now, sometimes they use zucchini instead of a potato. It's all the same procedure. You're just changing whether you're using potato or zucchini. So what you're going to do with the core is you're just going to push this through. Okay, so I'll do it in front here. You're going to push this through. Okay, and that's going to give you a slice of the potato. And you can use this little splint here to push that potato core right out. Okay, and we will pull that out. Okay, and you're going to need a bunch of them. They look like little French fries. Okay, we're going to need a bunch of these so that we can put one in each container. And it's really, really important that before you drop these in and run this experiment, that for each potato core that you place in each container, that you find the starting mass, because we're going to see how much does it change. And then when we graph that percent change, we'll be able to use that graph to determine the molarity of the potato cell. So I'm going to just go ahead and make a couple cores, and I'll talk to you about what will happen. So let me go ahead and do that. Okay, so we have our potato cores all set up. We want to make sure that we weigh each one. We find the mass of it, make sure you record it in your data table, and then we're going to drop it in one in each container, and we're going to leave it there overnight. So we can load these in and leave it there for 24 hours. Now, when you come back the next day and you remove these potato cores, you want to make sure that you dry them off, because we don't want to have the mass of the water, and you're going to, after you dry them off, remass them and put that in the data table. At that point, you're ready to calculate the percent change. What you will do is take the final mass minus the initial mass, divide it by the initial mass, and times it by 100. And that shows you your percent change. Now, negative numbers, if you should get a negative number just represents that it went down in mass, and a positive number means that it obviously increased in mass. And you should kind of have an idea of what to expect on your knowledge of osmosis. And I do have another video that goes over hypertonic, hypotonic, and isotonic solutions. So when we are kind of anticipating what we should get, when we put this potato core in distilled water, that's pure water. And it has a higher water potential than the cells of that potato, because there's dissolved material in the potato cells. So that water should be moving in to the potato cells, and we should see an increase in mass here. Now, with the 1 molar solution, that 1 molar solution might, probably, you would have to test to see, have more solute in it than the potato cells. In a situation like that, the potato cells are going to lose water, and it's going to see a decrease in the mass. And you will see how these other molarities will affect the mass of the potato core. And then when you graph that, you're going to have a graph where you see positive numbers, you're going to see 0, and you're going to see negative numbers. Right where that line intersects the 0, at that molarity, that is the exact molarity of your potato core. And that's how you would figure that out. It would be the same way if you were doing a zucchini cube or a zucchini sphere, an apple, same idea. You would look for that change in mass. So that's it. I hope that helped, and I will see you next time. Okay, if you'd like to go over the video where we talk about plasmolysis and hypertonic, hypotonic, and isotonic solutions, click here. If you'd like to subscribe to the channel, click right there.